Hello and welcome to HTML5 Transitions and Animations. My name is Mario Pajala, and in this series of videos we're going to be learning about all the technologies that are available today in HTML5 that will allow you to make basically a transition or an animation. And some of these technologies, such as DOM, are pretty old, but some of them are quite new, such as CSS3 that has tools that will help you make transitions and animations. It has keyframes and keyframe animations. It has transitions that are very easy to use. You'll also have SVG, which we are also going to be discussing, that are basically vectorial graphics. The HTML5 canvas object, of course, which may look hard to use, but once you learn the basics, it's very easy. And finally, we have the monster, the massive WebGL. Now, WebGL is the most complete of all technologies, and it will also allow you to do 3D animations. But all of these technologies, of course, are very complete. And it would be practically impossible to cover every single detail about every single technology in under 2 hours. For WebGL, we would need at least 40 to cover it entirely. So we are going to take a different approach here. We are going to be learning the foundational theory behind every single thing, and we're going to give you a glimpse and a starting point into every single animation method. So this is not meant to be a complete guide into each technology. There are several books out there that Pact probably publishes that covers each technology in particular, but this is meant to be the complete guide into all technologies that will allow you to make a transition or an animation with HTML5. So in this very first chapter, we are going to be learning the difference between a transition and an animation, which is subtle, but it exists. What is a vector, and how we can use vectors in practical examples. Then we're going to be discussing easing and acceleration, which will make your animations much smoother. And finally, we're going to be talking about interpolations. So that's basically it. In the next video, we are going to be discussing the difference between a transition and an animation. See you then. Welcome back. In the last video, we gave a small introduction to the world of transitions and animations in HTML5. And in this particular video, we are going to be learning the difference between a transition and an animation. A transition is actually quite simple. It's just a set of properties that go from A to B. It's that simple. Now, you will notice the following. Let's suppose we have a square on the screen, and that when we mouse over the square, it turns green. When we remove the mouse from that area, it goes to red again. Well, that's a simple transition. That's basically making a transition of colors, right? From red to green, and from green to red. It's very simple. A transition could also be something that combines both things, such as color transformations and size transformations, such as this one, goes from red to green and also increases its size. So it's actually very simple to understand. Now, animations are a bit more complex, right? So an animation could perhaps be explained as a series of transitions. So for example, let's take a look at the following example from Three.js. So we have a horse running, but if we would just focus on 2 frames, you would notice that the legs are moving on those 2 frames. So it could be perhaps considered a series of transitions that goes all together. So it forms a complete animation. It doesn't have a predefined path like a normal animation. For example, this other example, it's a bit more complex. Now, the things you can do with this is actually very nice. You will notice this in other chapters. It's all up to your imagination, basically, because you can use this as a method of perhaps making a picture larger or making a link larger. It's up to you to use a transition to make that. Now, if you want to make something a bit more complex, something that flies around the screen in a spectacular fashion, well, in that case, you might have to use an animation. It's not a transition, it's a bit more complex. So that's basically it, really. In the next video, we are going to be learning about vectors, which are basically essential knowledge. So see you then. Welcome back. In the previous video, we saw the difference between a transition and an animation. Now, in this video, we're going to be learning about vectors. And vectors are these abstract concepts that everyone finds so hard to understand, but they are very, very easy if explained properly. So, I'm going to try to do my best job to explain what a vector is to you. So, a vector is this arrow that is located in space. Basically, it flows from a certain point of origin. In this case, that point of origin is located in a Cartesian chart at 5 in the x-axis and 2 in the y-axis. And vectors have the head and the tail. And depending on where the head is located, it basically allows you to infer some basic properties about the vector itself. Besides the direction, vectors also have length, and that length is called the magnitude. And this is how it's represented. So in this case, the length of this vector is 5. And we'll know how to get this number in a minute. Like I was saying before, the point of origin in this particular case is 5 in the x-axis and 2 in the y-axis. But vectors do not care. They only care about the direction and the length. So in this particular vector, we can see that it goes 4 positions to the right and 3 positions up. Another way to say it would be 4 horizontally and 3 positions vertically. And here's another 4 positions in the x-axis and 3 in the y-axis. Now, this is a normal way of expressing that. Both numbers are positive. That means that it goes to the right and up. Now, if we saw this other example, we would see the point of origin has changed to 9 in the x-axis and 2 in the y-axis, and the vector now goes -4 in the x-axis and 3 in the y-axis. So we can probably see that this vector goes to the left and up. It goes to the left because -4, it is negative. And here's another example. It goes -4, -3. -4 in the x-axis, -3 in the y-axis. This time it goes to the left, down. And the point of origin, in this case, is 9 in the x-axis, 5 in the y-axis. So how do you calculate the magnitude? Well, we use variation of the Pythagorean theorem. This is how you use it. And you need to input that information of the x and the y-axis in this formula, and that's all you need to. It's really simple. Now, besides vectors, you also have points. Points do not have a direction, do not have length, but they do have position inside a Cartesian chart. So in this case, this point has 6 in the x-axis and 3 in the y-axis. It's located on that point. If you combine that with a vector of 2 and 2, it allows you to calculate where that point could move. So in the next video, we'll learn about some vector operations. See you then. In the last video, we saw a small introduction to vectors. Now let's see how we can apply those concepts to real-world examples. Let's suppose we have a vector, and this vector goes, for example, 6 in the x-axis and -3 in the y-axis. What would happen if it found a vector going in the opposite direction, that goes -6 in the x-axis and 3 in the y-axis? Well, they cancel each other out, and the result is 0. So these two vectors have equal length, but opposite direction cancel each other out. Another example would be a vector that we want to scale by 2. And this 2 is called a scalar value. And all we need to do is to multiply the original value by 2. So 6 by 2 and -3 by 2. And the result is 12 and -6. And you will notice that it is a vector exactly like the one we had before, but twice as long. Now let's suppose that we want to add two vectors together. And in this case, all we need to do is to basically add 6 and 3, right? 6 plus 3, and -3 plus 2. And remember that vectors perhaps are relative to the point of origin. So in this case, we can place these two vectors together. This is vector A, this is vector B. And we can place B here. And the result of the sum of elements is 9 and minus 1. So if we had to make a new vector, right, this results in a new vector that starts where vector A started before and ends where vector B ends. And it has obviously 9 and minus 1. So we can apply this concept fairly easily. Let's suppose we have a plane, which it will be a point. A plane does have a direction, and this plane travels this vector every second. Well, let's suppose that obviously this vector has 6 in the x-axis or minus 1 in the y-axis. But let's suppose this plane finds a current of wind, has 4 in the x-axis and 3 in the y-axis. Well, all we need to do is to add them up, and the result is a new vector. This new vector can help us predict where the plane is going to be. So, now let's suppose that we want to multiply two vectors. And this has a name. It's called finding the dot product. And all we need to do here is to do A1, 6, by B1, 3, plus A2, minus 3, by B2, so 2. So all we need to do is this, and this returns a number. And this number is very important to find this angle here. And this angle is called theta, and it's represented by that symbol. And there's a theorem that gives us this. So we can basically move stuff around here and get to this point. So we already know that this dot product is 12. Now we need to find the magnitude of A and B. So I have already pre-calculated the results. These are rounded values. 5.2 by 3.6. The result is 18.72. And again, rounding values. And if we divide 12 by 18.72, the result is 0.64. And that's equals to the cosine of theta. But if we move cosine to the other side, and then we multiply, we get 0.88, right? And that's, again, rounded. And that's the value of this angle in radians, which, if we convert it to degrees, would be 50.4 degrees. And that's the value of theta. So, in the next video, we'll be talking about easing and acceleration. In the last video, we discussed some vector examples, and now it's time to learn about easing and acceleration, which is practically essential knowledge to make a smooth transition or animation. So, back in the first videos, you probably must remember the properties were being animated in this fashion, right? So, they were being animated constantly, it wasn't a straight line. So, if we had to track properties such as position throughout time, we would notice that it is constant. The movement is constant. This is not always true. There are other easing functions that we can use. An easing function takes 4 parameters, mostly. A start value, a change in that value, a time, which is the current time, and the total duration of the animation or transition. For the purpose of this video, we're only going to be discussing 3 types: linear, quadratic, and cubic, but there are many others. And the interesting thing is that we can use different easing functions for each property. So, for example, we can use a linear easing function for the x-axis and a cubic easing function for the y-axis. So, in a linear easing function, there's no easing and no acceleration. It's just a straight line. It is constant. In a quadratic, there are 3 types. There's in, out, and in-out. Same goes for cubic. So, in a quadratic in acceleration, objects accelerate from 0. That's the formula, and you'll notice two time variables are being used, that's quadratic. And this is the result. You will notice the position or the value being accelerating from 0 towards the end. In a quadratic out, objects decelerate to 0. This is the formula, and this is the result. So it starts, and then at the end, it starts decelerating. And you'll notice that it is the exact opposite. In a quadratic in-out, objects accelerate from 0, and towards the end, they decelerate to 0. That's the formula, and this is the result. You'll notice that they accelerate at first, and halfway there, they start decelerating. Cubic in, out, and in-out, they start just like quadratic. And the difference is very subtle. You'll notice that this time we're using three time variables. That's why it's called cubic. And you'll notice the acceleration at first in the in animation. In the out variation, objects decelerate to 0. And the result is this. Just like in quadratic, it is the exact opposite. Now, in in-out, just like in quadratic in-out, objects accelerate from 0 and decelerate to 0 towards the end. And that's the result. So, in the next video, we're going to be discussing how to interpolate two values in order to smooth them out. In the last video, we discussed some easing formulas and how to handle acceleration of values and such. Now we are going to be discussing how to do interpolation of values. So what's that? Well, let's suppose we have a series of points in space. Let's remember that unlike vectors, points do have a position in space. So we need to trace a path, we need to go through all these points. So if we just used lines, this is what we would get. And this is quite rough. We want to smooth out the path that we are taking. So we're going to call each one of these points control points. And we do know, remember, that each point has a position in space. So for example, we have 0 in the x-axis and 2 in the y-axis for the first point, 10 in the x-axis and 16 in the y-axis for the second, and so on. And our objective would be to smooth out all these rough paths into something more like a curve. So we wanted to follow this path, or similar. So let's make this example a bit shorter, and we're only going to be doing this with just 3 points. Now that we have this information, point 1, point 2, and point 3, the value on the x-axis and on the y-axis, we're going to be applying this formula. This formula is called the quadratic Bezier curve. This is an image taken from Wikipedia where you can see the entire formula. So how do we translate this into JavaScript? This is how you do it. So as you can see, we apply the same formula for the 2 points, or for actually any value that we want to use the formula with. So for example, for the x-axis, we do have 0 for the first point, 10 for the second, and 19 for the third. Same with the y-axis. We have 2 in the first point, 16 in the second point, and 8 in the third point. T is the current time. So that's how you apply the formula. This is actually a literal translation of this mathematical language to JavaScript. But let's take a look at that piece of parameter, that parameter there. It says that where time is between 0 and 1. So what is it talking about? You probably must remember from the easing example that we have time, which was the current time, and the total duration of the animation. In this case, it's just the same. But what this is asking for is a value of the current time between 0 and 1. And the reason why is because it tells us when do we need to place the object here or here and such. So knowing this, let's say that, for example, the current time is 3 seconds and the total duration of the animation is 20 seconds. So in this case, there's a very easy way to handle this, which is to use this sort of simplification of clearing x. So if we have 100, where 20% is 100, and 3% we actually don't know how much that is, we would need to multiply 3 by 100 and divide the result by 20, therefore clearing x, which returns 15%. In this case, it's just multiplying by 1 and divided by 20, which can also be expressed as 3 seconds divided by 20. That means the result is 0.15 seconds, and that's the parameter we need to use. So that's the end of this chapter. In the next chapters, we'll be applying this set of formulas to practical examples. So see you then. Welcome back. In the previous chapter, we learned about the mathematical concepts and formulas we needed to know in order to perform a transition or an animation using HTML5. In this chapter, we are going to be rendering elements using the document object model. This is actually quite simple. It's one of the simplest to use methods to render elements. You have probably done this in the past if you're somewhat proficient with JavaScript and HTML and curious about making transitions or animations. So we're going to be starting this project by creating a blank HTML5 file. We're going to be defining the HTML5 doc type, creating some HTML tags, and of course the header. There it is, the head tag. We're going to be defining a title, in this case rendering elements. And now the body tag, there it is. And within this body tag, what we're going to be doing now is to include a JavaScript file that in our case is going to be called script.js. So we will need to create a script.js file, and within script.js we are going to be creating what's called a self-calling closure. And the advantage of using a self-calling closure is that it encapsulates what's contained within from the global scope of the browser. This is actually a very good practice. I suggest you to do this with every single JavaScript project that you have. Now, within this function, we're going to leave it empty for now. But what we're going to be doing is to add some default parameters, such as passing the document object. And we're going to be referencing document using the $sign. So every time that we want to call a method in the document object, we are going to be referencing the $sign. So in the next video, we're going to be rendering elements using the document object model. See you then. Welcome back. In the previous video, we started developing the foundations of our web application, right, of a website. Now in this video, we're going to be rendering elements using the document object model. We're going to start, first of all, by generating an event, right? So when the page has finished loading, we're going to be doing some other things. So first of all, we need to do add event listener and reference the DOM content loaded event. And now we need to create a reference to the body tag. We can do so by using getElementsByTagName, which will return several elements. So we need to reference the first one. And now we need to dynamically create an object by using createElement, and we're going to be dynamically creating a div object. Now we need to set some basic properties such as width of 100 pixels and a height of 100 pixels. And let's set a red background by using background color F00. Now we need to add this element to the body tag. We can do so by using appendChild and referencing the object that we just created. When we refresh the page and we load this example, this is what we get. Now, if we want to change the position of this element, we can do so very simply by using position absolute or position relative. So we can set position absolute, then we can set a top, left, right and bottom properties. So in this case, I'm going to set top 200, left 400 pixels, and the result is obviously that. But there's an alternative, which is to use translate function in CSS. And we can do so by using, for example, WebGL transform, Mars transform, MS transform, and just transform, the 4 variations. And then using translate text in this case, we can also use translate Y or even Z if that's possible, or just translate, and then we can specify with commas, right? The first parameter is the x-axis, y and z-axis. So when we load this example on the screen, that's the final result. So that's good. In the next video, we're going to be learning how to render elements on the screen using the canvas object. So see you then. In the previous video, we started to learn how to render elements on the screen using the document object model. Now in this video, we're going to be doing the same using the canvas object. Now we're going to start with a very similar foundation to what we had before. So we're going to be obviously adding the DOM content loading event and making a reference to the body tag using the getElements by tag name. And of course, now we need to dynamically create a canvas object, just like we did with a div. So we're going to start by creating a canvas variable, and inside it we're going to be using create element. This time we're going to be specifying canvas. Now we need to call what's called the context of the canvas. So we need to use the canvas method getContext. And in this case, we're going to be using context 2D. Now, if we try this example right now, what we're going to get is a blank page, as you can see. First, remember that we need to add the canvas to the body, because right now it's created in the memory of the computer. It's not added to the document object model. So if you append the canvas to the body, that's what you'll get, which is a blank page. And the reason why is because the canvas is empty. So by default, canvas has a default width of 300 pixels and a default height of 150 pixels. We're going to change that by specifying canvas.width 300 and .height of 300. Now we're into referencing the context, and we're going to set a default fill style. We'll be using to set the default color. So fill style, and we're going to set black. Now to draw things on the screen, we are going to be using the fill rect method, which allows us to create a rectangle on the screen. And this takes 4 parameters. The first one is the position in the x-axis. The second is the position in the y-axis. The third is the width. And the fourth, the last parameter, is the height of a rectangle. So in this particular case, we are going to say that we want to make a rectangle that is as tall and as wide as the canvas itself. So when we refresh the page, that's the final result. Now in the next video, we're going to be learning a bit more about canvas. So see you then. Welcome back. In the previous video, we started to learn how to render things on the screen using the canvas object. Now in this video, we're going to be using the same structure we had before. Obviously, we need to remove all the references to the fill rect method. And we're going to use pretty much the same things, right? A reference to the canvas, to the context. We're going to be setting a width of the canvas to be 300 pixels and the height to be of also 300 pixels. And lastly, we're going to be adding the canvas to the body. And we're going to start by creating a new image. So if we do image, we create the image variable and we create a new image object and we specify the source of the image, in this case HTML5.png. To use this image, we cannot use it yet because it's not loaded. So before we use the image, it's very important to realize that it needs to be loaded, alright? We cannot use it as it is. So there's one very easy way to do this, which is to use the add-event-listener method and listen the load event of the image itself. Then we specify callback and then we run the entire thing within this callback. There are much better ways to do this. This is just an example, right? So after we do this, we can use the drawImage method of the context of the canvas to display the image. And the first parameter is the image itself. And the second and third parameters, in this case, are the position in the X and Y axis. The result is this. So we can see that the image is too big, won't fit. Well, luckily for us, a drawImage accepts other parameters, such as being able to specify the width and the height that we want this image to have. So let's say 50 by 70. And the result is that 50 pixels of width by 70 pixels of height. Or we can also say that we want this image to have the width of the canvas and height of the canvas. And the result is that. So that's it. In the next video, we're going to be learning how to render elements on the screen using SVG with Raphaël. Welcome back. In the previous video, we learned how to render elements on the screen using the canvas object. Now in this video, we're going to be learning how to do the same using Raphaël. Raphaël is a framework that allows us to simplify how we work with SVG, which is vectorial graphics. And it's actually very easy to use. It's very simple. So the first thing that we need to know about Raphaël is that it simplifies how we work with SVG, which is very verbose. So we're going to start by opening a web browser and going to the following URL, which is raphaeljs.com. And when we go to this URL, we need to click on download right there. I have already downloaded this library. I have already downloaded Raphael-main.js to my computer. And obviously the first thing that we need to do is to reference this framework in our HTML file. So I have already, as you can see there, referenced Raphael. And now we're going to be editing script.js, and we're going to start with blank structure, right? A basic structure of the dump content loaded event. And we're going to be creating a canvas, which is not the same canvas as before, and creating Raphael using the Raphael function. And we're going to specify the position of the canvas, the width of 300 pixels, and the height of 300 pixels. Alright, so just like we did before, we are going to be creating a rectangle. This rectangle, we need to reference the canvas and obviously use the rect method. And we need to specify the position and the width of the rectangle itself. So let's specify not 100 pixels by 100 pixels. If we want to set a red background, just like we did in the document object model example, we can use the attribute attr method, use fill and the red color. The result is that, which is beautiful. In the next video, we are going to be learning a bit more about Raphael and how to use SVG. See you then. Welcome back. Now, in the previous video, we started to learn how to render elements on the screen using Raphael and SVG. Now, in this video, we're going to keep learning how to do things with this fantastic framework. So this is the example that we have created a canvas
in x0, y0 with a width and height of 300 pixels. Of course, we needed to reference Raphaël-min and the script.js in the page. The rest is basically empty. Now, to display an image, we can do this, for example, right? We can create a new image object and we can specify the source. Let's use the same image as we used before. And we can then use the image method of the canvas object, which is not the HTML5 canvas object, but Raphael's own canvas object. So we need to specify the source of the image. In this case, it's image.source. And the other two parameters are the position in the x and y axis. And then we can specify the width and the height that we want this image to have. And that's about it, really. We don't need to load the image. That's taken care of by Raphaël. So the example, it works just fine. If we want to create a circle, for example, obviously we need to create a circle variable and then do canvas.circle. And the first parameter is the position of the x-axis. The second is the position of the y-axis. The third parameter is the radius of the circle itself. So now with a radius of 100, we can see that the circle shows up behind the image. And the reason why is because the order matters, right? If you display the image before, well, it would show up on top of it. So there are ways to overcome this, obviously, but that's basically how it works. In the next chapter, we're going to be learning how to animate things. So see you then. Welcome back. In the last chapter, we learned how to render elements on the screen using Canvas and the document object model and SVG with Raphaël. Now we're going to be setting up a conventional rendering scene. So in this chapter, we're going to be learning how to set up a rendering scene in this video, how to use the document object model to animate objects, or how to use CSS3 transitions and keyframes. We're going to be using SVG with Raphaël to animate objects. And then we're going to be learning how to do the same using the HTML5 canvas object. Actually very, very nice. So we're going to start with a very basic page, just like we used before, right? So we are going to be including Raphaël and script.js. And our script.js is only going to have this reference to the body tag. Conventional rendering usually has what's called an update loop, right? So we're going to create a function called update. We're going to place it there, right? And obviously we need to call this update function. The purpose of this update function is to update itself all the time, right? So we can update things all the time. And we cannot actually call update again like a recursive function. For example, if we type update here and we run this example, it would crash the page. The reason why is because this is not C or C++. There are alternatives such as using setTimeout and specifying the number of milliseconds, right? In this case, 10 milliseconds. And obviously, setInterval goes outside this update function, but we can use setTimeout and setInterval using the same syntax. The problem with these two methods is that they are not aware of the state of the browser. They're not aware if the Windows is not focused or if we are not looking at the screen, so they consume very valuable resources such as battery life. So there's a more efficient way of calling the update function, which is by using request animation frame, which is a new function in HTML5. Unfortunately, it's not widely supported with that name, so we need to do some sort of thing to fall back to all the different methods. So every browser usually implements its own function name, right, for request animation frame, which is aware of the current state of the browser, right? It is aware if the window is unfocused. So let's open up Google and let's Google request animation frame Paul Irish. And Paul Irish is a developer that made a shim, right, that we can use to overcome this problem, okay? And if you scroll down, there's that code that we can basically copy and paste, right? Let's copy that function, and it obviously falls back to set timeout automatically. And let's paste it around here, there. All right, there it is. Now be careful, because as you can see, it has a fallback to set timeout if none of the other functions exist on the browser. So we're going to start by copy and pasting the request anim frame function. And be careful, because it's just request anim frame. And let's put that. Let's delete that parameter. Be careful. All right. And that's it. The request animation frame will continuously call update. All right. So that's very nice. It will continuously call update. In the next video, we are going to be learning how to animate things using the document object model. So see you then. Welcome back. In the previous video, we learned how to set up a conventional rendering scene. Now in this video, we're going to be using the document object model to animate objects. Let's start with a very basic example that we had before, right? That rendered that square on the screen. So this is the code, and I just added the update function to that piece of code, right? As you can see below. So we're going to start by taking these two parameters and adding them down there inside the update loop. So if we try this example, you will notice that nothing happens. The square remains static. The reason why is because that value, that 10, never changes, right? So we're going to start by, first of all, defining two variables, x and y. And we're going to say up there, right? We're going to say that both x and both y have a value of 0, of not. Good. So now, in order to change the position, what we can do is to increase, for example, the value of x every time that update is called. And let's add 2 to x. If you refresh, you will notice the square slowly starts moving to the right until it gets out of the screen, right? And that's not very nice. So in order to prevent that from happening, what we can do is to create a velocity variable, such as vx, which is like a vector, right? So let's say that vx is 4, and let's put vx there, right? It adds the value of vx, in this case 4. However, now we need to check the boundaries. So we're going to be asking if x is x plus the width of the object, in this case 100, is bigger than the client width of the body, which is the width of the browser, or it is below 0, which is, the border to the left, then we need to multiply vx by -1, therefore turning it into -4. So instead of adding 4, we would be adding -4. And the result is this. Boom, it bounces back and forth It keeps on moving forever. And this is actually very useful to know. This is an example that has been used historically by screensavers. So you can now make your own screensavers with HTML5 and the DOM object. And we'll be using this, this very basic example of adding VX and such throughout other examples, whether we work with the document object model or we work with SVG, or we work with WebGL. And it's very simple to use and to understand. Now, in the next video, we'll be learning how to animate things using CSS3 transitions. Welcome back. In the previous video, we learned how to animate objects using the document object model. Now, in this video, we're going to be animating elements using CSS3 transitions. And to create a transition using CSS3, it's actually very simple. We're going to start with the very basic page that we had before, and we're going to be creating a div with an ID called square. Then we're going to be creating a style sheet, or in this case a style tag, and we're going to be specifying some properties such as, in this case, the background color of red, and a width of 100 pixels and a height of 100 pixels. And the result is that, right? It's not very impressive. So we want to do this. When we mouse over this square, we want the background to change to green. We want the width to change to 400 pixels and the height to change to 200 pixels. Alright? If we try this, you will notice that the change is very abrupt. Okay? There's no transition between the two states. But we can, luckily for us, solve this easily with CSS3 transitions. And let's do this. Let's start by specifying the transition property. And this takes many parameters, which are very optional, but let's say that the first parameter is always the property that we want to animate. In this case, let's say width. We want this animation to last for 2 seconds. And it accepts additional properties such as, the easiness style, and let's specify ease out in this case. And it supports other properties such as the delay, if we want this animation to be delayed. Alright, let's leave it like this for now. The problem with transition is that it's still a spec, so we need to specify what's called the browser prefix in order to make it work. So, there are many browser prefixes, one for each browser, but for example, for Safari and Chrome, we can use WebKit transition. Now Opera has changed to WebKit as well. For Firefox, we need to use Moz. For IE, we can use MS. And for Opera, we can use O. For the sake of argument, let's use WebKit. And let's specify the same amount of properties that we specified in the original transition attribute. So when we try this example, you will notice that the change of the width is making a transition from point A to point B. Alright? Now, if we want to animate additional properties, we can do so by specifying them with a comma, right? So let's add comma, height. We want this animation to last for 4 seconds instead of 2. And let's use an ease in instead of ease out. And let's make it wait for 1 second before being animated. We need to specify the same in WebKit transform. If we try this, you will notice that both the width and the height are making a transition from point A to point B, and that the height is waiting for 1 second, which is the delay that we specified. So originally, if we want to animate the both states, right, we will need to place that same amount of code in the original function. There's no need to specify it in the hover state, right? If we want to animate all properties, we need to use all and then specify the time, the result. That's for the sake of argument, place the hover state as well, but it's not necessary. If we try this, you will notice that all properties are being animated at the same time. In the next video, we're going to be learning how to use CSS3 keyframes. Previously, we saw how to animate objects using CSS3 transitions. Now in this video, we are going to be learning how to do the same using CSS3 keyframes. Now it's actually very similar to use to CSS3 transitions. We're going to start by placing the square inside a container, right? So we need to create the container now. Container, and we're going to set a relative position and let's say a blue, somewhat bluish background, the width of 500 pixels and a height of 300 pixels. And to the square, we're going to be assigning an absolute position with a left of 0 pixels and top of 0 pixels. And the result is that, alright? Nothing very impressive yet. So when we mouse over the container, we want the square to be animated, alright? To go to each of the corners of the container. We're going to be creating a keyframe animation to do just that. But first, we need to create the actual keyframes that define the animation. And we can do so by using the keyframe keyword. And the syntax is at keyframe, and then we need to specify the parameters of the animation. So first of all, we need to define the name of the keyframe, and we can either use from and to or percentages, like in this case 0%, and inside that 0% we can use the amount of elements, the attributes. We can specify the attributes that we want to animate. So remember to add the prefixes. So for the sake of argument, I'm just going to copy and paste set a keyframe, an existing keyframe. And you will notice that on 0% it starts on the top left, on 25 goes to the right, and so on and so forth. So it's actually a very simple animation. Well, the square will move from corner to corner as the animation is being played. I'm also going to copy and paste the syntax on how we configure and we use a keyframe animation. And it supports these properties, such as, first of all, the name of the keyframe, alright? So in this case, it's called test, and the animation name is called test. The duration, in this case, 5 seconds. The timing function is the how the transitions will be eased. So let's specify ease in out. The duration count, in this case, it's 1, but it could be 2, 3, or infinite. Alright? And finally, we have the direction of, in this case, which is normal. Alright? So if we play this, there it goes. Beautiful. Alright, so that's very simple. In the next video, we're going to be learning how to animate objects using SVG with Raphaël. See you then. Welcome back. In the previous video, we saw how to animate things using CSS3 keyframe. And animating things using Raphaël is really not that different from using keyframes because it works very similarly. So we're going to start with what we had before, which is like a square in the top left-hand corner. And the code looked like this. Actually, it was actually more like this, right? So rect.attribute. But one of the nicest, perhaps, features of Raphaël is that it allows you to change attributes together, right? To make that sort of one-liners, which are very easy to understand. So to animate objects, we can use the animate method. Just like in CSS3 keyframes, and this is how similar it is, we can, let's specify an object, and the first parameter, let's say 0%, and we can also define which properties are going to be animated inside. So let's continue. Let's make 25%, 50%, 75%. There you go. And finally 100%. And within this object, within this attribute, we are going to be specifying which properties we want to animate. So in our case, we want this element to start we want this element to move. So we're going to start with x0, y0, x 280 pixels, y0, x 280 pixels, y 280 pixels, then x0, which is now going to the left, y 280 pixels, and finally both properties back to 0. Alright, so if we try this, you will notice that nothing happened. And the reason why is because we need to to specify how much time this animation should last. So let's specify 4000 milliseconds or 4 seconds. You can see the beautiful animation that it produced. It's very smooth. And we can also specify different easing formulas per method. So let's use bounds for the first one, is in for the second, is out for the third, is in out, is in and out, and finally bounds in the last step. And we can see the beautiful animation that it produces, and that's basically it. In the next video, we're going to be using the HTML5 canvas object to animate elements, so see you then. So far we have learned about how to animate elements using SVG and the document object model and CSS3. In this video, we're going to be animating elements using the canvas object. So we're going to start with the code that we had before, right? With the example that we had before, which was just a black square in the screen. And the code looked like that, and I have added the update loop. So let's start by making a small red square. So let's use fill style red and fill rect. Remember the origin points 0, 0, 20, 20, which is 2020 would be the width and the height. Okay, and the result is that. Okay, and as you can see, it's positioned in the top left, and the reason why is because we're specifying 0 and 0, which is 0 in the x-axis and 0 in the y-axis. If we want to modify these two variables when the update loop is called, we are going to be using a similar technique to what we used in the DOM example. We're going to be creating variables x 0, y 0. We're going to be specifying them down there, right? And if we modify the value of x and we try it, you're going to notice something weird happens. And the reason why is because Canvas works in immediate mode. And it works like a piece of paper, right? You need to, if you draw a line, right, you need to delete what you draw before in order to make that a small bit of line appear to move without making it continuous. So there's a very easy way to fix this, which is to draw the black rectangle again, like that. So every time that the update loop is called, we draw the black rectangle, we modify the position of x, and we draw the square. And that's the result. But as you can see, it goes off the screen. So we need to check, we need to add the velocity in the x-axis. Let's add 2. And check the boundaries. Exactly like we did with the document object model example. So specify x, and we can say that if x plus 20, which is the width of the square, is bigger than the width of the canvas, or x is less than 0, we need to multiply the x by -1. And the result is that. It is that simple. Now, in the next video, we're going to be learning how to do more difficult examples, more complex examples with HTML5 canvas. Welcome back. Now, in the previous video, we saw how to make a very basic animation using the HTML5 canvas subject. Now, in this video, we're going to be learning how to do more complex animations, such as this one, where the shape is rotating along the path of a circle. And this is actually very easy to accomplish. All you need to do is to define some additional attributes, some additional variables. So this is how it looks. We have the x and y, right, variables like we used before. Then we define an angle, right? Such as there's the angle variable, which in this case starts in 0. And then there's the radius, which is half the width of the canvas, minus 20 pixels, which is the width and the height of the square, right? Now, then, to modify the position, we need to obviously use the sinus and sine and cosine formulas, right? Functions. And then we need to increase the angle or multiply it by the radius, as we can see here. We can modify the radius, of course, make it smaller, and there it is. It goes much slower. And if we want to make it faster or slower, let's make it slower in this case. As you can see, it's barely moving, or much faster. Like we can see here, it's moving very, very fast. So that's one example. This other example, remember the formulas that we explained in the very first chapter? Well, here they are, right? All implemented in JavaScript form, right? So we have linear, quadratic in, quadratic out, and quadratic in out. So let's switch to the other example. So in this case, the square is using a linear animation. The transition, the X property, is being animated using linear acceleration. So we can see here that the animation is constant, right? The movement is constant. But we can change it to quadratic in. We can see that towards the end, it starts to accelerate, right? So that's quadratic in. Or we can also use quadratic out. And quadratic out produces the inverse result, which is starts at constant speed and towards the end starts to decelerate to 0. So that's very simple. And finally, we have quadratic in and out. And as we can see here, starts accelerating and towards the end starts to decelerate. And it produces that result. So let's take a look at what's happening here. I am defining the start on 0. We have a time and a duration of the animation. Alright? So the time in this case is 0.2, as we can see below. Obviously the change is going to be the width of the canvas minus 50, which is the width of the rectangle, of the square in this case. And we can change the time to make it slower. So let's go back to quadratic in, which is much more obvious. And the result is that it's slowly moving, it's slowly accelerating using quadratic in, which is very simple to use. So we can also make it accomplish the same using duration 100 and define obviously a time of 1 and produces a similar result. So it's actually very easy to use. In the next video, we are going to be learning how to render and animate elements using WebGL. See you then. Welcome back. In the previous video, we learned how to animate elements using the HTML5 canvas object. Now, in this video, we're going to step it up a notch and learn how to use WebGL with Three.js. And WebGL is basically a port of OpenGL ES, and ES stands for Embedded Systems. The problem with OpenGL and WebGL in general is that it's very hard to use, it's very verbose, it takes a huge amount of lines to accomplish the simplest of things. Luckily for us, there's a framework called Three.js, developed by Mr. Do. I think it's called Ricardo Cabellos from Barcelona, Spain. And it's a fantastic framework. There are alternatives, but my favorite is Three.js. And in this chapter, we're going to be downloading and setting up Three.js. We're going to be, in the next video, introducing cameras, and then we're going to render simple geometries and animating geometries. We're going to be importing models from Blender, which is similar to 3D Studio and Maya, which are 3D softwares. We're going to be rendering imported models and animating imported models. So we're going to start by going to Three.js.org. There it is, the Three.js homepage, and then we're going to be clicking on the left on download to start the download. And that's going to trigger the file download, which is like a somewhat large file for a web framework. It's a 75 or 80 megabytes download. I'm going to delete this download, and I have previously downloaded this example that will need to extract into a file system. So I'm going to be extracting the Three.js zip archive into the file system. So once the file is extracted, now we'll need to move that file, we need to rename it, and to move it into our project folder because we'll need to reference it in our HTML page. So there it is. Let's rename it to Three.js. And now that it's renamed, we'll need to open our project folder here. Alright? So that's our project folder, right? It has the page, the Raphaël, and the script. So let's move that folder here. There it is. So in our HTML page, on HTML5, we'll need to make a reference to the Three.js folder. And I have already added the reference. It's Three.js /build/3.min.js. Well, it's very, very simple. So that's going to include the Three.js framework. And that's all we need. So inside the script.js, I am basically using the same structure that we have been using before. I'm going to delete the canvas. I'm going to add a reference to the WebGL renderer. Three.js has several renderers that we can use. I'm going to be creating a scene and setting a default size of 300 pixels of width by 300 pixels of height. And finally, I'm going to be adding the element to the body and obviously calling our update loop. In the next video, we're going to be setting up cameras and working with cameras. See you then. In the previous video, we downloaded and set up Three.js. So in this video, we're going to be adding a camera. And so far, we have worked in 2 dimensions, right? But Three.js, it's more suitable to work in 3 dimensions. So 3 dimensions, all they do is to add one more axis. In this case, it's the z-axis. So we have x, y, and z. So if we had an object in the scene, we would need to have a way to look at it somehow, because the screen is still 2 dimensions. And that's where cameras come in. Cameras define what's called the frustum of the camera, which is a visible area of the 3D space, a 2D representation of the 3D space. So we can position cameras, in different sort of angles. We can turn them to the right and to the left, top, bottom. We can get them far away or near the object, like that. So to create a camera, all we need to do is to define some basic properties, such as the angle, let's say 45 degrees, and then we can define things such as the aspect ratio, which is in this case 300 divided by 300, which is the width and the height of the renderer, and the minimum level of zoom, in this case 0.1, and the maximum level, let's say far to be 10,000. And then we need to create the camera using all these attributes. So let's create perspective camera and specify angle, aspect, near, far. So we have created the object. Now we need to add it to the scene by using scene.add and specifying the camera object. And now we need to define some basic properties for the camera. So we need to define position. The z-axis is going to be 300. And that's it really. In the next video, we are going to be creating simple geometries. See you then. In the previous video, we saw how to set up a camera and how to download and set up Three.js. Now in this video, we're going to be rendering a simple geometry. And a geometry is nothing more than a shape in 3D space. It could be a sphere, it could be a thing such as a cube or a cylinder or a 2D plane, right? So a geometry and a mesh is composed of these small points, and these points are called vertex. So we would need different vertices to form a shape. So for example, to make a square, we would need to define 4 vertices. So if we define 4 points, that will make a square. Now in your GPU, the graphical processing unit of your computer, that square would automatically be converted to what's called a triangle strip, like this. Now, it doesn't matter if you define a square, it will automatically be converted to a triangle strip to be used by your GPUs. And each vertex will have its own position in 3D space. So like in a 2D, we have the same sort of positions in 3 dimensions, right? And this is how a cube would look like, or how a sphere would look like. If you pay attention, you will notice all the triangle strips. And we can also define materials, such as colors or textures. Or there are other ways, such as using shaders, which are outside the scope of these videos, basically to give it color or an image, or texture, and such. So it's very, very simple. So that would be the final result, right, of a sphere plus the geometry plus the material would make that mesh. So to set up a very simple geometry, This is the example that we had before. And to create, for example, a cube, we would need to define a cube variable and use 3 cube geometry, that's the name of the method, and define, for example, the width, the height, and the depth, of course, of the object. Then we are going to be creating a material using mesh basic material. We're going to be calling it again new 3 mesh basic material, and as a parameter we're going to be passing an object that has the color attribute, and we're going to be giving it a hexadecimal value of blue 0000FF. Now we need to create a mesh. We need to call the mesh method, and we need to specify the cube, which is the geometry, the material of the mesh itself. Now we need to add it to the scene by using the add method again, and we only need to pass mesh, and that would add the cube to the scene. Now we're going to be making a new function called render, and inside render we're going to be calling the renderer.render method, and we're going to be specifying the scene and the camera that we want to use. And finally, in the update, we are going to be calling render. The result is that blue cube. So in the next video, we're going to be learning how to animate geometries. In the previous video, we saw how to render a simple geometry. Now in this video, we're going to be animating that geometry. So to animate a geometry, all you need to do is actually very simple, very similar to what we have done so far. So let's go back to the script, and we're going to be defining some other properties such as width and the height of our screen, of our renderer. And we're going to be using those variables in the future. So we need to replace the aspect and set the new size of the renderer. The result is that, so it has made the renderer bigger. You cannot see the boundaries, right, the border, but it's bigger. And now, if we want to modify this mesh, we can reference mesh dot, we can either use rotation or position, right? So we can, for example, use rotation dot x to rotate it in the x-axis. We can use 2, and the result, no, that's way too fast. Let's make it a bit slower. So like that, and let's enable the wireframe by indicating wireframe true. The result is that, a beautiful 3D cube rotating in space, alright? Now, that's rotating slowly, very slowly, but we want to make it move, right? So if we wanted to rotate it using the other axes, we need to specify rotation.x, y, z, right? So to make it act like previous examples, all we need to define is a couple of additional properties, such as the velocity and things like that. So let's create the velocity variable, and let's say that it equals 2. Let's change it to the x. And inside update, what we are going to be doing now is to say if the position of the mesh in the x-axis is bigger than the width of the viewport divided by 2 minus 100, which is actually the width of the cube, or the position of the mesh in the x-axis is less than the width of the viewport divided by 2 multiplied by minus 1 plus 100, we want Vx to be reversed, right? So we multiply it by minus 1. Finally, we need to set the new position of x, and we need to add Vx. The result of this operation, let's some sort of error here, let's try it. No, it seems to be not working. Let's see what's wrong. It probably has to do with the parenthesis somewhere. Oh, there it is. So if we try this example, we'll notice that the cube now works and it's animated and it's bouncing off the screen, which is fantastic. Now in the next video, we're going to be learning how to import models from Blender. See you then. In the previous video, we learned how to animate geometries. Now in this video, we're going to be importing models from Blender. And Blender is a 3D software, very similar to 3D Studio Max or Maya. It is open source, it is free, and you can download it right now. So, it's basically a 3D software and thus the scene. So what we're going to be doing now is to add an object to this scene to create this object. So we're going to click on Add Mesh, and we're going to be creating a monkey head, a very funny monkey head. And we can see the camera, and it has a frustum, so we can move that around. And we can see that the camera is pointing at the object. We can see here. Now, in order to basically export the entire scene, including the cameras and the lights and the object itself, we would need to add an exporter, right? And luckily for us, Three.js includes support for many 3D softwares, such as Blender itself, and Maya and 3D Studio Max. It's actually very convenient. So to configure that thing, if we open the Three.js folder, within Utils, Exporters, and Blender 265, we have Scripts, Add-ons, IO Mesh 3.js. And we would need to copy this folder, right, has those files inside the Blender plugin folder. So depending on your operating systems, the path could be different. There's obviously Windows, OS X, and Linux. On OS X, if you want to open that folder, you need to go to the application, right-click on it, and click on Show Package Content, which will give you access to the Contents folder. And so I have already copied mine, and then we need to go back into Blender, click on File, and there's an option called User Preferences. So click on that option, it opens a new window, and on that search box on the left, type Three.js. So there it is, import export Three.js format. It is currently disabled. So that checkbox there, you need to click on it. That enables the plugin. So if we want to export this scene, we need to go back to File, Export, and it should show Three.js, which will open a new window, which will allow us to export the entire scene, including the cameras, the lights, the meshes. We can have more than one mesh, obviously. And it says export 3H and such, and it says experimental. And make sure that all 4 checkboxes are checked, but obviously you can select which ones you want to include. I have already exported mine, so I'm going to be using it here. I'm going to be creating a scene loader. So I'm going to be calling it monkey loader, and that's new 3, and we need to call the scene loader, and then we're going to be referencing monkey loader, and we're going to be calling the load method and specify the JS file that Blender exported. This callback of the load function will obviously pass result, and then we can use that result to access all the different methods of that object. So we're going to be replacing the camera with the current camera in Blender, and the scene with the current scene in the Blender file. And the result is that, right? A beautiful monkey head. In the next video, we are going to be animating complex geometries. See you then. In the previous video, we learned how to import models from Blender, which is a 3D software. Now, in this video, we are going to be learning the theory behind complex animation systems with several moving parts. So, usually when we discuss complex animations, we can imagine ourselves to have a timeline. In this case, the timeline has 5 seconds. And we have already used the concept of keyframes in the past to indicate that at several points in time, objects should move one way or another as time goes by, right? So that's actually very simple to understand. So in the case of a complex animation, we can either define each keyframe by itself and, for example, say that on second 1, the wings of a bird should be there, right? So let's suppose we have a bird. In second 2 would be there, and 3, 4, and 5. Now, if we play this animation back and forth, would give the illusion that the bird is flapping its wings. But we can also define just the first point, the starting point, and the end point, and do an interpolation of all the moving parts, right, between the starting point and the finish point, and it would result in the same sort of animation. So in a more complex system, in a human being, for example, being animated, we would find it to have several moving parts at the same time. So if we are walking while we are lifting our arm and turning our head, the head would be just a very simple animation, right? So we would be turning our head to the left, for example, and then we would need to define a starting point and a finish point of the rotation. The same with the arm. We're just lifting our arm, right? Would be just the starting point and the finish point. But if we are walking, the animation of the leg involves several steps, right? It is not just a starting point and a finish point of one piece of it, but rather we also need to count the knee as well, the rotation of the knee, because it is being rotated as we walk. So as every single step is made, the knee is also being rotated, and that also counts as a keyframe because it is a stopping time to make a different sort of animation. So let's take a look at it more in detail. Let's suppose we have a leg, right? We would be tempted to make it work like that. But in reality, we have the thighs, right? So we have the hip, rotation at the hip level. We have the knee, right? So we have a rotation at the knee level, right there. And finally, we have the ankle that allows us to rotate our feet as we walk around. And in computer graphics, that bone structure, it is represented like this, right? So those diamond things would be the bones, and the small diamonds would be the rotation points. So I'm not going to go into much more detail on this, but show you that the movement, obviously it is a bone, and the movement of one bone affects the other. So for example, if we have the entire lower body, we have the hip on the top like a tree, and then we have the upper left and upper right leg. Okay, so we have the upper left leg, and the upper leg, the movement of the upper leg affects all the other bones, such as the knee and the lower left leg, ankle and left foot. But the movement of the lower leg affects the ankle and the left foot, right? So if we rotate the knee, we are actually moving the position of all the other bones in our body. So that's the sort of things we need to keep in mind. In the next video, we're going to be learning how to animate complex objects. Now that we know the theory behind complex models, like we learned in the last video, we're going to be learning how to animate imported models. And we're going to be using a model from the Rome project, which is important to give attribution. So we're going to be using a horse from the Rome project. So we're going to start by first of all having our JS object in the file system, and we need to first of all, like we did with the monkey loader when we exported that scene from Blender, to do a loader. And this time we're going to be using Three.js loader, and we're going to be specifying true. Now we're also going to be creating an empty mesh and the duration of the animation, let's say 700, and the number of keyframes, which is 15, and the interpolation, which is obtained by doing the duration divided by the number of keyframes, like we have learned in previous chapters. Finally, we are going to be defining two other additional properties: last keyframe and current keyframe. So to basically use the loader and to load that horse with several keyframes inside, we're going to be using loader.load and the name of the file, which is horse.js, that we need to specify callback, and that callback will return a geometry, the geometry data. So let's specify G. And now we need to create a new mesh. So 3 mesh, and we're going to be passed G, and in this case we will need to specify the material. We're going to be using mesh Lambert material. There are other materials such as foam material and flat shader, but in this case we're going to be using mesh Lambert material. And we're going to be obviously setting a color of the model, let's say gray. That's the hexadecimal number. And we're also going to be specifying more targets to true to smooth out the animation. Now, we also need to basically set a basic scale of the model, let's say 1, 1, 1. And we're going to be rotating the model, so you can look at it. We're going to be using mesh.rotation.y 90 degrees. Finally, we need to add the scene. Let's use scene.add and mesh, which adds the mesh to the scene. So let's preview what we have. Alright, it's loading and it's a black horse. Why is it black? Well, because it's not being illuminated by any light sources. So we need to create a new light source. Luckily for us, that's very easy. Let's create a new light variable, new 3 directional light, and let's set the color. Let's say white. FF, intensity, I think that's intensity. And we need to set the position of the light, 1, 1, 1, and normalize the vector. Finally, we need to add the light to the scene. So scene.addLight. If we preview the example, we can see a beautiful horse. Alright, perfect. Now, to animate it, I'm going to copy and paste a bit of code that I have worked on, and I'm going to be pasting this basic piece of code within the render function. Now let's fix this. Let's go ahead and fix this. So if the mesh is loaded, otherwise it will crash, that routine will be executed. So the result is a beautiful horse running. In the next video, we'll be learning how to do complex animations.
In the previous chapter, we learned how to work with WebGL. Now, in this chapter, we're going to be making a small basic introduction to
sprite sheets. And sprite sheets are a concept that come from the world of animation, right? Of cartoons, basically, such as Disney's Mickey Mouse or Aladdin's or Warner Brothers Bugs Bunny. So in cell-based animation, each single image is static, right? So by using several static images, you can give the illusion that an object is moving. So for example, let's take the animation of a horse running. So we have the first frame, third, and the fourth. And every time it's played, we get the illusion that the horse is moving its legs, right? When we look at a single frame. And this technique has been used extensively by video games, and it continues to be used extensively by video games, for example, or even by other softwares, right, to for example, represent explosions and such. So it has been used in Sonic and Street Fighter, Mortal Kombat, and Braid, and the list goes on and on. In thousands of games, probably. So that's basically the core concept. So let's first of all, let's see how a sprite sheet looks like. So usually a sprite sheet is this file of full of static images, right? So for example, this is a good example. So you can see that this sprite sheet has many frames. So each single animation is called a frame. So in this case, it's a fox that it's running, and we can basically see that each particular frame has obviously some set of information. So for example, this animation has 12 frames, and each frame has a width of 153 pixels of width by 139 pixels of height. So it's very, very simple to understand. Sometimes this is called an atlas, but usually an atlas is a combination of several sprite sheets. So when we play the animation, right, it's one by one, right? So we play the first animation and the second and such. And the result is this animation. The more frames it has, the smoother the animation will be. So in this case, this is a sprite sheet from the game Glitch, and in this case we can see that the animation is very smooth, and it takes a really long time to learn how to make a very smooth animation. So the artist that made this sprite sheet was very talented. So as we can see that, the animation is played one by one, right? So let's see how we can implement in a sprite sheet. First of all, we need to load the image. So let's go ahead and create a new image. Let's specify the source. And now let's obviously attach the event listener. Load, and there's the callback. It is called update. So when the image is loaded, update will be called. And within this update function, we are going to be drawing the image on position 0, 0. Let's leave it like that for now. The result is this, but you will notice that the image looks pixelated. And the reason why is because, remember, there it is, all the pixels. Remember that Canvas works in immediate mode. So it is drawing the image over and over and over again on itself. So to solve that problem, we need to use clear rect. And it takes 4 parameters: the position of the x-axis, the y-axis, the width, and height. In the next video, we're going to be learning how to animate in a sprite sheet. So see you then. In the previous video, we saw an introduction to sprite sheets. Now, in this video, we're going to be implementing a sprite sheet animation. So let's continue where we left off, right? So we had a sprite sheet with 12 frames, right? A width of 153 pixels and a height of 139. So this is the code that we had so far. First of all, we are going to be specifying the number of frames and the width, which was in this case 153 pixels and a height of 139. Good. So in the draw image, we are going to be using another syntax. Remember that it supports multiple syntaxes. So we're going to be specifying 120 by 120, and you'll get that because it's shrinking the whole thing, which is shrinking the whole image into 120 pixels by 120 pixels. So let's set first of all the width and the height of of each frame. And besides this syntax, draw image, right, like that produces that example. Besides this syntax, draw image supports another syntax, which allows us to specify an offset. So in that case, in the first scenario, the second and third parameters will be the position of the x-axis, and the fourth and the fifth, the width and the height of each frame, and the sixth and the seventh, the position of the x and y-axis this time. So if we run this example, this is the result, right? So we have a nice fox. But if we modify that parameter, look what happens. Did you see the fox being animated? What happens is that we have specified an offset, and it's no longer in the position 0, but rather in the second position, right? It has moved 153 pixels to the right, and therefore it plays the second frame in the animation. So let's see how we can integrate this. Let's go back and create a new variable. Current position 0. Alright. And now we're going to be multiplying the width by the current position. So in the first case, when it's 0, the result will be the first frame. Good. But if we increase current position, it will get multiplied by the width. So first of all, we need to basically increase the current position every time that we call update. But we need to check that the current position is not greater than the maximum number of frames, right? So in this case, the sprite sheet has 12 frames. So we need to basically limit how much current position can store, right? So we're going to ask if current position is equal to the maximum number of frames minus 1, we are going to be resetting current position back to 0. And the result is that very fast animation. And the reason why it's playing so fast, as you can see there, is because we're using request animation frame. And request animation frame is playing this animation at 60 frames per second. So I'm going to leave as an example as an exercise to you to modify that method. So for the moment, we're going to be replacing request animation frame with set timeout, and we're going to be specifying 200. Let's use 50 milliseconds of delay. And there it goes. That looks way better, right? So that's basically it. I'm going to leave as an exercise to you to modify the original example to use request animation frame and to play this animation at 24 frames per second. So in the next video, we're going to be learning about particle generators. In the previous video, we saw how to make a sprite sheet animation. Now, in this video, we're going to be learning how to make a particle generator. And particle generators are basically very useful tools to know because so far we have only worked with single moving objects. And particle generators will basically teach us how to work with multiple animations, right, that move simultaneously. And particle generators can be used to represent many different sorts of objects. And these objects are as varied as smoke animations or fire or asteroids or, smoke, those sorts of things. So they are actually very convenient. And a particle generator is composed by two main components: particles themselves, right, all the independent particles, and the particle generator or particle emitter itself, which is the tool that generates those particles. And each particle has four sets of properties in 2 dimensions: x, y, the velocity in the x-axis, and the velocity in the y-axis. And in 3 dimensions, it adds the z-axis, right? So the z-axis and the velocity in the z-axis. It's actually very easy to understand. So far, so good. And we're not just limited to handle single particles. We can use images as particles, or we can generate particle generators that themselves generate other particles. So, we can go crazy with this and do several sorts of things. So let's see how we can implement a particle generator. We need to start by creating the particle object itself. And obviously in 2 dimensions, this will take the 4 parameters we discussed before. So the x, y, vx, and vy. So let's define the initial methods, and we'll say that if x is defined, then it will take the value of x. Otherwise, it's going to assign 0 as the default. So let's do the same with y. If y is defined, use y, otherwise use 0. And the same goes for vx and for vy. Okay? So now we are going to be adding an update method that will be called every time that we want to update the particle. And we're going to be able to pass to this function 2 parameters, vx and vy. So we're going to be asking if vx is defined, then we're going to be assigning vx to the vx. Otherwise, we're going to be using 0. And then we're going to be adding the value of vx to the x-axis and to the y-axis. So it's actually very simple to understand. So let's do the same for the y-axis, defining this vy plus vy, and that's about it. Now the particle generator itself, it's also very easy to accomplish. We're going to be creating a particle generator object that will take some parameters, such as the container, which will be the canvas that we'll be using to draw the particles, the center object, which we'll be using to center the particle, to position the particle, and how many particles we want to generate, which is the count. So we're going to be getting the container from the canvas to be able to draw in it, and we're going to be assigning, obviously, do a basic integrity check with a count, And then we're going to be generating an array where we are going to be storing all the particles. And that's about it. In the next video, we'll be continuing with the development of a particle generator. In the previous video, we started to develop a particle generator, and in this video, we'll continue with the development. So far, this is what we had. We had a particle generator object and a particle object. And the particle generator object had that particles attribute that we'll be using to store all the particles. First of all, we're going to be defining the position where all the particles are going to be generated. So we're going to be using the center variable, and the center variable is going to be an object where we'll need to specify x and y with the center of the particle generator. So now that we have defined the center, what we need to do is to generate the particles. And if you paid attention, you will see that I have initialized I with 0. We're going to go through all the count of particles, and for each one, we're going to be assigning the center in the x-axis, the center in the y-axis, the velocity in the x-axis, let's say 1, and the y-axis, let's also say 1. And now what we're going to be doing is to basically generate the particles. So we're going to be adding new elements to these particles attribute. So we're going to be creating a new particle object, and we're going to be passing as parameters x, y, vx, and vy. So it's actually very simple. So this will basically take care of generating all the different particles down there, right? Down in that line. So we have that, we have defined the center, and now it's time to start integrating the particle generator in the main block of code. So we're also going to be adding an update method to the particle generator. And this update method will take care of calling the update method of each particle. So again, we need to go through the count of all the different particles that we have. So let's change this to this count, and yes, that's fine. Looks fine, I think. And let's also make that reference to the canvas. So let's add the for loop, and within this loop, what we're going to be doing is to basically call the update method of each particle. But first, we need to check the boundaries of each object, because remember that particles could be outside the screen. So we need to check that the particles are within the screen. And if they are within the screen, we're going to stop processing. Otherwise, it's going to always process the particles whether or not the particle is being displayed on the screen. And that's a complete waste of resources. So we're going to be basically checking for the size of, we're going to be checking the boundaries of the object itself. And y would be less than this container, the height, and we need to add that width up there. All right. So if this meets the conditions, we're going to be calling the update method on the particle itself. So this is basically how it will work. Right. So finally, we're going to draw the particle itself by specifying the position of the current particle being processed in the x-axis, obviously, and the current particle in the y-axis, and we're going to be giving it, representing it with a 5 by 5 pixel square. In the next video, we'll continue with the development. So let's go ahead and finish our particle generator that we started in the last video. So far, this is what we had, right? So we had the main block of content software. We generated the particle generator class and a particle object itself, right? That had a lot of different parameters, so that's wrong. So all we need to do now is to generate the particle generator, okay? To actually create a variable with the particle generator to start using it. So let's create a new particle generator. We're going to pass the first parameter, which is the container, in this case canvas, and the origin point, which, remember, needs to be an object. So we're going to be passing the canvas width divided by 2 and canvas height divided by 2 to generate things in the middle of the canvas. And finally, we are going to generate 100 particles. Okay? Now, within the update loop, we're going to be calling the update method of the particle generator, which itself will call the update loop of every single particle. But first, we need to remember that canvas works in immediate mode, so we need to clear the canvas. So we'll be using fill style black, and we'll be drawing a rectangle using fill rect that goes from 0, 0 to the width and the height of the canvas. So that will paint the entire thing black. And now we need to set back the color, right, to white. So let's set fill style and white. So this will generate white particles. And let's remember to call update. But notice this. When you run the example, only one thing seems to be generated. The reason why this happens is that if we go back in the code and we look at the generation parameters within the particle generator, when update is being called, you will notice that both Vx and Vy are 1 for each particle. One easy way to fix this is to actually specify a random value using math random, right? So we're going to be doing math random by 3 minus 1.5. Okay, so you can basically tamper with these values as you prefer. So the result is this. But we're not just limited to drawing, squares, because that looks a bit ugly. So instead of drawing a square, we can do this. We can first, for example, declare a new image, such as a smoke image. So let's call it the smoke, right? Smoke image. So we're going to be loading, creating a new image, and we're going to be specifying the source as smoke.png. And let's go down and say that we should only run the update loop if the smoke image is loaded. So let's add a new event listener and call the load event. So when the image has finished loading, it will call the update function. And now, instead of using full rect, we can use draw image of the canvas method and specify the image and the origin point, so of each part. And the result is this. And that's a beautiful example of a smoke generation. And you can tamper with the values being passed to the update method of each particle and pass additional parameters, and you can play with the generation parameters and such. So these are other useful resources you can check. These resources will work for all projects, for all other videos. So in the next video, we're going to be talking about some practical examples. So far, thank you for watching. Welcome back. In this last chapter, I wanted to discuss some practical examples on how to use all the different animation methods that we have learned so far. And we have seen how to work with a whole variety of technologies, from the document object model to CSS3 to SVG to WebGL and Canvas and such. Now, the thing with all these technologies, and I think that the most convenient animation method for 85% of developers is CSS3. And the reason why is because it's, first of all, very easy to master, because the syntax is very, very easy to learn. It works absolutely everywhere. It has great performance, unlike the others, which the performance varies greatly depending on the device you're using. You can start using it right away. It is supported in most major modern browsers. It's actually very, very simple to use. And if you know how to master it, you will be able to accomplish things that look beautiful, that are useful. And again, for 85% of developers, CSS3 will be the tool to use at the time of making an animation or transition. And I'll show you why in a minute. And before we continue, I wanted to basically tell you why we made these videos. And the reason why we made them was not to give a complete insight into each technology, but rather give you a good, solid introduction into every single animation method available in HTML5, right? WebGL alone would take years to master, so that's basically it. So in this first video, we're going to be working on this card flipping example. But let's see some things that I have made with CSS3 that you won't believe in. So this is, for example, my personal website. So that's my face. You can see that I make like several expressions, several facial expressions. There's like a glare on my face and that sort of thing. Well, this is all accomplished with CSS3. Okay? I'm using several keyframe animations and different textures to give the illusion that I'm perhaps blinking or smiling, that sort of thing. The same goes for that button on the top right. It's very smooth animation, and it's an interface element that looks very well. The same goes for example, this game that I've made. It's called Bubble Pop. You will notice that many of the elements that show up here are made with CSS3. Actually, when you click on this title screen, you will notice the title screen fading away. The same goes for this comic book, this animation of the comic book. This, for example, title screen with a level selection screen, sorry, with all the levels. That's all made with CSS3. The game itself is made with Canvas, right? But these interface elements are made with CSS3, and they have a great performance in both mobile as well as desktop computers. So this is the example that we are going to be working on, which is a card flipping example. So as you mouse over each card, the card will rotate to reveal an image. And that image is actually hiding underneath that black square. So as we can see here, I'm going to delete this part to show you the image. So if you refresh, you will notice that there's an image underneath each module, right? Each, not module, but each square, all right? So the intention is that this card will flip in 3 dimensions to reveal that image. So we'll continue with development in the next video. See you then. Welcome back. In the previous video, we started to work on a card flipping example. So let's continue with the development. So let's switch to the code. And the first thing that you will notice is that each element has a transition attribute. Remember to add the proper prefix if you're working with other browsers. So this transition property will basically smooth out every single change that we make. And this is what we wanted to happen, is that the card will rotate. The problem is that when it rotates, we want to hide the side that is underneath. To make it rotate, we can use the transform function and then specify rotate Y, and we're going to be rotating it 180 degrees. So let's try it. Let's see how it looks. So this is how it looks, but can you see that we can still see the word, what's on the card? So we want to hide the card if it's rotated 180 degrees. So we don't want to see the back side of the card itself. To prevent that from happening, we need to add a special property that's called backface visibility hidden, like so. So if we refresh, you will notice that the card is gone because it is rotated and we can see the images. And we need to do the same with images. All right, so if the image is rotated, we don't want to see the image. So let's add the same property, the same backface visibility hidden property to images as well. So let's go ahead and type backface visibility hidden. Okay, perfect. So now we have different hover states. So when we hover over the container of both the image and the paragraph that contains the actual description of a card, we want the image to rotate 180 degrees. So that would be minus 180 degrees to the right. And we want the paragraph to, so if you try it, you'll see what happens. Right, it rotates, it works just fine. So we want to do the same with a paragraph. We want to transform and then rotate Y, and we need to specify 0 degrees. And the result is this. And it looks somewhat great, but it could be a little bit more dramatic. To add more dramatism, and by that I mean more perspective, we can use the perspective attribute. Let's specify reasonable values such as 700 pixels. The final result is this. It looks beautiful, really looks beautiful, and the clicks works, and it looks great. So in the next video, we're going to be making a clock using CSS3 and keyframes, plus a couple more other tricks. So see you then. Welcome back. In the last video, we learned how to make a card flipping example. Now, in this video, we're going to be learning how to make a clock with CSS3. And making a clock with CSS3 is actually quite simple. Drawing the clock itself, we can do that with border radius. And the hands are just divs, right? In this case, are spans. One is short, the other is long. It's a very simple structure, right? So we have the two hands of the clock. And let's add some properties. First of all, we're going to be defining keyframe animation. And keyframe animation is going to be called rotate. And we're going to tell it to go from transform minus 360 degrees to 0 degrees. And the reason why we're doing it this way is because we want this example to work in clockwise fashion. All right, it will rotate in a clockwise fashion. So we have this rule here that affects both hands. So let's specify the animation attribute. Remember to use the prefixes, the proper prefixes. So let's specify the animation name, make it last 10 seconds and be infinite. So this is what happens, right? So we can see both hands rotating with a bit of an acceleration. First of all, let's specify linear. Now the movement is linear, it doesn't have an acceleration. But the origin point of the rotation is wrong. So let's fix this by using transform origin, 50% of the x-axis and 100% of the y-axis. And now it looks right. It is rotating just fine. And for the long hand, we're going to be specifying 20 seconds instead of 10. And that's animation, not animate. So we can see that one hand rotates faster than the other. But the movement is linear, and that's not good. However, there's a function in CSS3. Let's fix the time. There's a function called steps, and we can specify how many steps this animation will have. And it will automatically divide the movement in several steps. Okay? And finally, this is what we get. A working clock, which is very impressive. Let's take a look at another example now. Let's suppose we have a square, right? And we want this square to rotate, but always being upright. I am going to be trying 3 different animation methods. This is one of them. You can see that it's trying to follow a curve. And here's another. Right? This time it rotates, but the square is also rotating. But finally, here's a trick by Leroy to make that same effect that we want to accomplish, which is the square rotating while remaining upright. And the reason, the way it works is by chaining attributes together. Because if you translate things first and then rotate, the order changes and it no longer works. So you can change those sort of transformational properties to make it do great things. So that's about it. This is the very last video. I hope you enjoyed the series, and if you have any comments, just please send them over. So goodbye.